Good morning. I'm Dr. Srilekha from the Department of Conservative Dentistry and Endodontics. My topic of discussion today is Enterococcus faecalis therapeutic options. It's a continuation of our previous discussion where we saw about the general characteristics of Enterococcus faecalis and its clinical significance in endodontics. Antimicrobial irrigating solutions and other locally used disinfecting agents and medicaments play a vital role in the eradication of the root canal pathogens, which is mainly responsible for causing the pulpal infection. The most commonly employed irrigating solutions are sodium hypochlorite, chlorhexidine, ethylene diamine tetraacetic acid, which is commonly known as EDTA, and we have MTAD. These are the most commonly used irrigating solutions during cleaning and shaping procedures. And in this discussion, we are going to see about this irrigating solutions. First, moving on to the sodium hypochlorite is regarded as a most potent disinfectant in endodontics due to its excellent ability to dissolve the vital and the necrotic tissues. In endodontics, it is widely used in the different range of concentration, that is from 0.5 to 6%, all of which demonstrates a very good antibacterial property. Enterococcus faecalis as a lipoteichoic acid in its cell wall, and when this E. faecalis is treated with sodium hypochlorite, it results in the impairment of immunostimulating activity by delipidation of glycolipid moiety of LP, that is lipoteichoic acid. This entire process is called as saponification. This sodium hypochlorite has an ability to impair the toll-like receptor to activation of this E. faecalis and induce inflammatory mediators and damage the lipoteichoic structure, potentially through deacylation, ultimately resulting in the cell death. Sodium hypochlorite exhibit a dynamic balance as shown in the following reaction. Sodium hypochlorite, when it combines with water, it dissociates to sodium hydroxide and hypochlorous acid, which further dissociates to sodium and hydroxyl ion, and you have H plus and chlorine release. With the exit of hydroxyl ions, there is a reduction of the pH. Hypochlorous acid, which is a substance present in the sodium hypochlorite solution, when it comes in contact with the organic tissue, acts as a solvent and releases chlorine that combines with the protein amino groups forms chloramine. This entire process is called as chloramination reaction that interferes with the cellular metabolism, ultimately resulting in the cell death. Hypochlorous acid and hypochlorite ion leads to amino acid degradation and hydrolysis. Chlorine is a strong oxidant, presents a very good antimicrobial action, inhibiting the bacterial enzymes, leading to irreversible oxidation of SH group, that is the sulfhydryl groups of essential bacterial enzymes. Berber et al. Assessed the efficacy of 0.5%, 2.5%, and 5.25% of sodium hypochlorite as an intracanal irrigant associated with hand and rotary instrumentation process against Enterococcus faecalis within the root canals and dentinal tubules. They found that 5.25% of concentration was very effective, followed by 2.5% of sodium hypochlorite. Coming to the second irrigant, that is the chlorhexidine, which is widely used in endodontics, the most common percentage that is employed is 2% of chlorhexidine. It's a synthetic cationic bisguanide, consists of two symmetric chlorophenyl rings and two biguanide groups connected by a central hexamethylene chain. Chlorhexidine is positively charged hydrophobic and lipophilic molecule that interacts with the phospholipids and lipopolysaccharides that is present on the cell membrane of bacteria and that enters into the cells of the bacteria via active or passive transport mechanism. Efficacy is mainly due to the interaction of the positively charged chlorhexidine molecule that interacts with a negatively charged phosphate group that is present in the cell membrane of the microorganism, thereby altering the osmotic equilibrium that exists within the cell. The time required for 1 and 2% of sodium chlorhexidine liquid to eliminate all the microorganism was same as compared to 5.25% sodium hypochlorite. The most important property of this chlorhexidine is substantivity. The positively charged molecules of chlorhexidine can be absorbed onto the dentin surface and prevent the microbial colonization. on the dentin surface for some time beyond the actual medication period. So this process of attachment of this chlorhexidine onto the dentinal surface and subsequent sustained release is called as substantivity. 2% chlorhexidine containing medications were able to thoroughly eliminate the Enterococcus faecalis biofilm. Coming to EDTA, it's a calcium chelating agent which binds to the calcium that is found in the dentin, and it forms a soluble calcium chelate, and it has reported that EDTA decalcifies the dentin to a depth of 10 to 30 micron meter in 5 minutes. The most commonly employed percentage is 17% EDTA. This EDTA, when it is combined with ultrasonic, was effective in removing the smear layer and debris from the canal, but EDTA did not have any antibacterial property. So it has to be combined either with sodium hypochlorite or with a chlorhexidine for better antimicrobial action, as well as for removing the inorganic debris, that is your smear layer. So EDTA along with cetavlon remove the smear layer very effectively. This combination is also available as EDTAC. MTAD is a new irrigant which was introduced in 2003 by Mohammed Torambanjan of Loma Linda University. It's a combination of tetracycline isomer, acid, and a detergent. This MTAD is a mixture of doxycycline, which is an antibiotic and which is effective. It has a broad spectrum antimicrobial activity, and citric acid, which is effective in removing the smear layer, and then polysorbate 80 or detergent, which is also called as tween 80, which is effective in reducing the surface tension for the better penetration of the irrigating solution. So MTAD is available as a two-part mixture which is consisting of powder and liquid. The antimicrobial effect of MTAD is largely attributed to the presence of doxycycline. It prevents the multiplication of the susceptible bacteria. That means it is a bacteriostatic agent. This bacteriostatic agent is proved to be very advantageous because it prevents the multiplication rather than causing cell lysis that results in the release of endotoxins that is quite very difficult to handle. And MTAD has a strong antimicrobial efficacy against E. faecalis compared to 5.25% sodium hypochlorite and 17% EDTA when used in combinations without affecting the dentin structure of the human teeth. So this is a table which is showing the properties of comparative properties of sodium hypochlorite, EDTA, chlorhexidine and MTAD. The biocompatibility is very good with EDTA, chlorhexidine and MTAD because if the sodium hypochlorite is not biocompatible if it is extruded beyond the periapical region because it may irritate the periapical tissue resulting in sodium hypochlorite accident. The ability for dissolving the pulpal tissue is very good with sodium hypochlorite, not with the other three. And antimicrobial activity is very good with sodium hypochlorite, chlorhexidine and MTAD. Ability to remove the smear layer is very good only with EDTA, not with the other three, and also with MTAD, and not with chlorhexidine and sodium hypochlorite. Dentin degeneration is seen in sodium hypochlorite and EDTA if it is used for a more if it is used for a longer span of time, and then it is also seen with MTAD. Inhibition of E. faecalis is very good with sodium hypochlorite, chlorhexidine and with MTAD. So we have seen the four irrigants that is widely used in endodontics. So to finally conclude, the understanding of the biofilm concept which play a key role in helping us to assess and understand not only the pathogenic potential of root canal microbiota but also the basis for new approaches for the better endodontic infection control. Thank you.